Hello everyone, welcome back, and today we are solving one of the classic problems, which is reverse linked list. This question is number 206, and let's get straight into it. The question is straightforward. Given the head of a single linked list, we should reverse the list and return the reversed list. We can look at the examples, then I will go to the blackboard, explain the algorithm, and then come back here, code the solution, and look at the time and space complexity. So looking at example 1, we see that the input is 1, 2, 3, 4, 5, and the output is the reverse of that list as 5, 4, 3, 2, 1. So we are given the head is 1, and as you can see, the program itself gave you all the nodes connected to 1, which is 2, 3, 4, 5. So our goal is to return the head of the new reverse linked list. And of course here the new head would be 5, and as you can see, LeetCode itself just wrote all the nodes connected to 5, which are 4, 3, 2, 1. So now let's go to the blackboard. Okay, I want you to understand something first. This question is one of the classic ones, and in the interview, if you get asked this question, the main goal of it, just for the interviewer can see whether you know how to do it or not. That's it. So don't try to be creative, think of new ways to do it. This is not the purpose of this question. The only purpose of it is just to show the interviewer that you know the algorithm to reverse a linked list. So here I have wrote everything that you need to know. We will go step by step through each note and make sure we understand every single line, and then we will go through the example and come up with the solution here, and then just type it out in LeetCode. Okay, so let's get started. Whenever you are asked to reverse a single linked list, we have to keep track of three things. One, the previous node, the current node, and the next node. These three variables are so important, and accordingly we have made 3 pointers: previous, current, next. This is the first step. Step number 2 is the algorithm itself. If this does not make sense yet, it's fine. We'll go through it step by step. But the algorithm goes as follows. 1. We need to keep track of the next node. We don't want to lose the next node, so we need to store it somewhere. And this is where the next node variable comes into place. Okay? Once we store the next node in a safe place, step 2 is basically the current node's next pointer will point to the previous node. For instance, let's say we are here, so this is the current node, so the current node next pointer is this. We want this pointer to point to the previous node. In this case, we don't have a previous point, so this will point just to null. So this will go here. For instance, if this is the current node, we will take the next pointer of this current node and point it to the previous node. So this would go here now. Okay, this is the purpose of B. Now basically step C and D are connected. We will see that when we do the example. The previous node will become the current node, and on D, the current node will become the previous node. We are just advancing the previous and current, and as I said, it will make way more sense when we do the example. Okay, so let's see. I'm giving you a single linked list, 1, 2, 3, 4, 5, and we are giving the head as 1. So step 1, keep track of the previous node, current node, next node. We made 3 variables accordingly, and at the start, the current pointer will point to the head. So we will take this current pointer and point it to the head, because we will start at the head, the current will be the head. So here is the current. Next, we don't know initially if we have a previous node or what is the next node, so we will point to null, to nothing. Initially, the previous pointer, next pointer will be null, and the only thing that we know for sure is the current pointer that will point to the head. Now in the while loop, we will literally put this algorithm as is. For instance, we need to store the next node somewhere, okay? So next equals the current node dot next, because the current node dot next is pointing to the next node. So next equals current dot next. Okay, now B is saying the current node next pointer must point to the previous node, as we just discussed. So current dot next, for instance, if the current is here, this will be current dot next, and we want this yellow arrows to point to the previous node. So current dot next equals previous. And now step 3 and 4 are connected. It's just saying the previous will become the current node, and finally the current node will become the next node. This is the algorithm. Let's see how it works. So starting here, the head is at 1, the current we know it's at 1, and we said previous and next initially they are null. They are pointing to nowhere. So starting with the while loop. And as you can see, I did not put the condition for the while loop because I want you to try to think about it. It will come clear to you as we finish the example. So keep an eye on this. Now let's start. Next equals current dot next. Okay, initially the next pointer is pointing to null, but we are saying we want the next to point to the current dot next. Okay, let's go to current. Here's current. Current dot next is pointing to 2, so now the next pointer is at 2. Here is next, and now it's not null. Okay, step number 2. We said that the current dot next equals previous. So we will take this arrow, which is current dot next, and it will point to previous. Previous is nothing, so this will point to null. Okay, good. Now third step. Previous becomes current, and fourth step, current becomes next. This is the advance. We call it the advance step. We want to advance the previous to where current is, and initially we said the previous is at null, so previous will go to where current is. Here is previous. Let's make it blue. And we want to advance the current to where next is. So take current from here and advance it to where next is. As I said, this is the advance step, and here is current. We just finished the first iteration. Again, let's do it one more time. Next equals current dot next. Okay, the next is at 2. What is current dot next? Here is current. Current dot next is pointing to 3, so we will move this next from 2 to 3. Here is next, and let's just move it from here. Okay, so the next step in the algorithm, current dot next equals previous. Current dot next is this yellow arrow, and it will point to previous. Previous is pointing to 1, so this arrow will also point to 1. Now step 3 and step 4 is the advanced step. Previous will point to current, and current will point to next. Previous will point from 1 to 2. Here is previous, and the current will point to where next is pointing at. You should start seeing a pattern. Okay, now let's go one more time. Next equals current dot next. Okay, so the next will move from 3 to 4, and now current dot next equals previous. Take this yellow arrow, and it will point to where previous is pointing to. Now step 3 and 4 is the advanced step. The previous will go to current, so the previous will come here, and now the current will go to where next is pointing at, and the current will go here. Let's go one more time. Now next will go to current dot next, so next will move from 4 to 5. Again, we will take the yellow pointer, which is current dot next, and it will point to previous. Finally, step 3 and step 4 is the advanced step. So the previous will move from 3 to 4, since current is pointing to 4. And the current will point to where next is pointing at. Since next is pointing to 5, the current will also point to 5. Now, last step. Next equals current dot next. So the next will move from 5 to null, since current.next equals null. Here is next. It will become null now. Now current.next equals previous. As always, take this yellow pointer, it will point to previous. Step 3 and 4 is the advanced step, so the previous will come to current. Here is the previous, and the current will go to where next is pointing. Since next is pointing to null, current will also point to null. Okay, so now we stopped when the current is null, because when the current is null, as we saw in the example, everything in the linked list is reversed. So in other words, we will keep looping until the current does not equal null. If the current is null, then we finish the whole reversing process and we will exit from the while loop. And as I said, we need to return the head of the new linked list. What is the head of the new linked list? It is pointed to by previous. So we should return previous. And that's it. So in summary, if you get asked to reverse a single linked list, you will say, okay, 1, we need to keep track of the previous node, we need to keep track of the current node, we need to keep track of the next node. So we made 3 pointers accordingly, a previous pointer, a current pointer, and the next pointer. Then the algorithm starts. We said step 1, we need to store the next node somewhere safe. We need to keep track of the next node. Now step 2, we will take the yellow pointer, which is current.next, and point to the previous node. Step 3 and 4 is the advanced step. The previous will become current, the current will become next, and we will keep doing that until the current does not equal null. When the current equals null, the whole process is finished, we break from the loop, and we just return the previous pointer, since previous is pointing to the new head. Let's go to LeetCode. We will literally put the same exact thing in code. And yeah, let's do it. Okay, so we said we need 3 pointer, previous, current, and next. We said that the previous and next will start as null, but the current will start at the head. Okay, so now we said we will have a while loop, and we will keep looping until the current does not equal null. Let's follow the steps. Step 1, we said, okay, we need to keep track of the next node and to store it somewhere safe. So we said next equal current.next. So next equals current.next. Step 2, we said that the current node next pointer needs to point to the previous node. Or if you look at the yellow pointer, we said we want to take this yellow pointer and point to the previous node. Okay, so current.next equals previous. And we said the step 3 and 4 is the advanced step. We said the previous will becomes current and the current will becomes next. Okay, and we said when we break from the loop, the whole process would be finished and previous would point to the new head. So return previous. Let's run the code. Let's submit. Okay, now let's look at the time and space complexity. If you notice that everything we did was only pure pointers manipulation, we just have 3 pointers, so the space complexity is constant, big O of 1. Now in terms of the time complexity, we used a while loop and we moved through the whole nodes of the linked list. If we have n nodes, the time complexity would be big O of n. I hope you guys enjoyed the video. Best of luck to you, and I will see you in the next one.